This is the first video in a new series called Spring Boot for Dummies. In this video, we will cover what Spring Boot actually is, why it exists, and how it removes a lot of boring setup work that plain Spring used to require. So, what exactly is Spring Boot? Spring Boot is a tool built on top of the Spring framework that lets you create a working Java application in minutes instead of days. It does this by setting sensible defaults for you, so you end up writing less code and less configuration to get the same result. Think of it this way. Spring Boot equals the Spring Framework plus auto configuration plus an embedded server plus starter dependencies. We will explain each of those pieces in this video. Here is a quick look at the code. This is a complete runnable Spring Boot application. That Spring Boot application annotation on top combined with this small main method is enough to start a fully working application. And if you compare Spring and Spring Boot side by side, the difference is clear. With plain Spring, you configure everything by hand. With Spring Boot, sensible defaults are already set for you. With plain Spring, you need a separate server like Tomcat. With Spring Boot, the server is already built in. To really understand why Spring Boot matters, it helps to look at what life was like before it existed. Before Spring Boot, setting up a Spring project means writing a lot of configuration before you wrote a single line of real logic. On the left, you can see what that looked like. You had to write XML files to wire up your beans by hand. You had to pick a server like Tomcat and configure it yourself. You had to manually match compatible versions of every library you used. You had to package your application as a WAR file and deploy it to that server. And you even had to write by boilerplate code just to read a simple property file. Now look at the right side. With the Spring Boot, beans are wired automatically through scanning. Tomcat is already inside your application. Starters bring matching versions together for you. You can run your application as a plain executable jar file and application. Properties just work out of the box. This is the entire reason Spring Boot exists. It takes all of that repetitive setup work away from you. Let's talk about one of the core ideas behind Spring called inversion of control or IOC. Inversion of control means your code does not create the object it needs. Instead, Spring creates them for you and hands them over. Let's look at an example without IOC first. In normal Java, a class like order service creates its own dependency. It says new payment service right there inside the class. This means order service is tightly coupled to one exact payment service implementation. If you ever want to swap that implementation out, you have to go in and change the code. Now look at the version with IOC. Here, order service does not create the payment service itself. Instead, it receives it through the constructor. Spring decides which payment service to create and it hands that object over. The class just receives it and uses it. The part of shipping that does this job is called application context. It builds, configures, and manages every object in your application for you. Now let's talk about dependency injection, which is how that principle actually happens in practice. Dependency injection or DEI is the mechanism. IOC is the idea behind it. There are two common ways to do this. The first is constructor injection, and this is the recommended way in modern Spring Boot. Dependencies are passed through the constructor. Spring sees that constructor and automatically supplies the values it needs. Because of this, your field can be marked final, which makes your code safer and easier to test. The second way is field injection, and this is something you should avoid in new code. Here, the at autovide annotation is placed directly above the field. It is shorter to write, but it is harder to unit test. and it hides what dependencies class actually needs, which makes it easy to forget something important. Look at this code example. We have an order service class with a final payment service field. Spring injects payment service automatically through the constructor right here. This is the pattern you should get comfortable with because you will use it constantly once you start building real Spring Boot applications. Next, let's look at one of the most powerful features in Spring Boot called auto configuration. Auto configuration is Spring Boot looking at what is on your class path and configuring beans for you based on what it finds. This all starts with one annotation at Spring Boot application. This single annotation is actually doing the work of three separate annotations combined. It is the same as combining at configuration, at enable auto configuration, and at component scan. All in one place. Here is how the process actually works. First, Spring Boot scans the jar files sitting on your class path. Second, it is finds a database driver in there. It automatically configures a data source for you. Third, if it finds a Tomcat, it configures and starts an embedded server without you asking from me. And fourth, if you ever define a bean yourself, your version always overrides the default that Spring Boot would have created. This last point is important because it means auto configuration never traps you. You always stay in control when you need to be. Let's talk about starters because these are one of the simplest but most useful ideas in Spring Boot. A starter is one dependency that pulls in a whole group of libraries that work well together, all at matching versions. Look at this example from a pom.xml file. This is just one dependency entry, Spring Boot Starter Web. But that one line brings in Spring MVC, Tomcat, Jackson for handling JSON, and validation support, all already version matched so they work together without conflicts. On the right, you can see some of the most common starters you will use. Spring Boot Starter Web is for building REST APIs and web applications. Spring Boot Starter Data JPA lets you talk to database using JPA. Spring Boot Starter Security handles authentication and authorization, and Spring Boot Starter Test brings in JUnit, Mockito, and other testing tools. Instead of hunting down 10 different libraries and hoping the versions are compatible, you add one starter and Spring Boot handles the rest. Here is another big reason Spring Boot saves you time. It comes with an embedded server. Spring Boot packages a web server like Tomcat directly inside your application so you never have to install or configure one separately. Let's compare the old way and the new way. In the old way, with plain Spring, you had to install Tomcat on the server yourself. Then you had to build a WAR file from your project. Then you had to copy that WAR file into Tomcat's folder. And finally, you had to start Tomcat and hope your configuration actually matched what it is expected. With Spring Boot, all of that becomes one single step. You run one command, java space dash jar space app.jar, and that's it. Tomcat starts up inside the very small same Java process as your application. There is no separate install, no separate server, and no WAR file involved at all. Now let's look at how a Spring Boot project is usually organized on disk. Every Spring Boot project follows the same predictable folder layout, and this layout is generated for you automatically by a tool called Spring Initializer. On the left, you can see the typical structure. Inside source and main, you have your Java folder containing your actual application code split into packages like controller, service, and repository. Inside resources, you have your application.properties file, which holds your configuration. And separate from all of that, you have a test folder for your test code. On the right, here is what each part is actually for. Application.java is your main class and it is what starts the whole application. The controller folder handles incoming web requests. The service folder is where your business logic lives. The repository folder is what talks to your databases. Application.properties holds your configuration values, and pom.xml is the file that lists all of your dependencies and their versions. Once you understand this layout, you will be able to open any Spring Boot project immediately, know where to look for what you need. Let's bring everything together with a full side-by-side comparison between Spring and Spring Boot. I recommend you to pause this video for a minute and just look in this. Before we wrap up, let's go through some annotations you are going to see constantly once you start working with Spring Boot. At Spring Boot, application marks your main class and enables auto configuration. At REST controller marks a class as a REST API controller. At service marks a class as holding your business logic. At repository marks a class as your data access layer, the part that talks to the database. At auto-void tells Spring to inject a dependency into a class. At component is a more generic marker that tells Spring to manage this class as a bean. At configuration marks a class that defines beans manually. And at value injects a single value straight from your application.properties file into field. You do not need to memorize all of these right now. Just keep this slide in mind because you will see every one of these annotation again as we go deeper into the series. Let's finish up with some common mistakes that beginners make with Spring Boot, along with the better way to handle each one. The first mistake is using field injection everywhere, where you place a auto-wire directly above a field. The better approach is to use constructor injection instead, where the field is marked final passed in through the constructor. The second mistake is hard coding configuration values directly in your code, like writing a database URL as a plain string. The better approach is to use application.properties along with the at value annotation to inject that value instead. The third mistake is putting too much logic directly inside your controller. Sometimes 50 lines of business logic crammed into one method. The better approach is to delegate that logic to a service class and keep your controller method short and focused only on handling the request. And the fourth mistake is catching every exception with the broad catch block and silently swallowing it, which means error disappear without you ever knowing they were happened. The better approach is to either handle the exception properly or let it propagate up to an at exception handler at the controller advanced level so you actually know when something goes wrong. Let's do a quick recap of everything we covered today. I ask you to pause the video and go through this. Let's meet in our next video soon. Thank you.